Recapping what we've been working on before we really move into the unit of covalent bonding. So, what we've been working on currently is ionic bonding, and an ionic bond involves the transfer of electrons. It is an interaction between a metal and a nonmetal, and another name for ionic compounds is salts. So, some common properties of ionic compounds: they're soluble in water, and when they do dissolve in water, they conduct electricity. Ionic compounds are not flammable. They have high melting and boiling points. They're a variety of different colors, and they're typically solids at room temperature. Then we moved into metallic bonds, and a metallic bond is just a bond between metals, or we can think of it as a bond within a metal, and it is just the attraction between metal cations and delocalized electrons. So remember that metals want to lose electrons when they're forming ions, and those electrons are able to freely float throughout our lattice, which is what keeps those metals together. Now, when we have a mixture that includes a metal, we call that an alloy. We covered substitutional and interstitial alloys. So a substitutional alloy is when a metal atom of similar size inserts itself into the lattice, whereas an interstitial alloy is when we have a metal with larger atoms, we have smaller atoms that kind of fit themselves into the cracks. So what exactly is a covalent bond or a covalent molecule? So when we're looking at covalent bonding, that is a bond between two or more nonmetals, and it involves the sharing of electrons. And the first thing we're going to be looking at are the electrons shared equally, or does one have more pull? So polarity is what we look at when one atom has more pull than another, or if the atoms are equally sharing the electrons. So a polar bond is when there is an uneven distribution of charge. One of my atoms is holding on to that electron a little bit more tightly. It has a partially negative charge, whereas my other atom has a partially positive charge. And we calculate polarity by subtracting the element's electronegativities. Now, we learned about electronegativity as a general trend. That is when one atom is able to pull an electron towards itself when in a chemical compound. But what we're going to look at now is we're going to look at electronegativities as numbers. So we can see here that fluorine has the highest electronegativity at 4, and then something like francium has a really low electronegativity at 0.7. So in a nonpolar covalent bond, there's a covalent bond in which the bonded atoms share electrons equally, and there is an equal distribution of charge. When we subtract their electronegativities, the difference is somewhere between 0 and 0.3. Now, if you have two of the same atom bonded together, in this example it shows hydrogen to hydrogen, you'll notice that the difference in electronegativities is 0. That's because both of those hydrogen atoms have an equal pull on their electrons. They're sharing them equally. Now, in a polar covalent bond, the atoms have an unequal attraction for the shared electrons. So one of my atoms is going to be partially negative, and the other one is going to be partially positive. Now, when we subtract their electronegativities, we'll notice that there's a difference somewhere between 0.3 and 1.7. So hydrochloric acid, for example, which is my HCl, has a difference in electronegativities of 0.9. That means that hydrogen to chlorine is a polar bond. Now, chlorine has a much higher electronegativity at 3.0 than hydrogen at 2.1. which means chlorine is really going to be pulling that electron closer to itself, making my chlorine partially negative and my hydrogen partially positive. So for today's assignment, what you're going to do is you're going to be given a whole list of different compounds. You need to determine, one, is it ionic or covalent? So remember, an ionic compound is between a metal and a nonmetal, and a covalent compound is between two or more nonmetals. And if we determine that it is a covalent compound, we're going to subtract the electronegativities. If it's above 0.3, it's going to be polar covalent. If it's below 0.3, it's going to be nonpolar covalent. Good luck.